Let's tackle this idea of position versus time graphs. We've been sketching them for quite some time now, and I just never quite gave it this formal name. In physics, we're going to be talking about particles, building models for particles, because this ideal object makes the analysis much simpler. An object that has no size or mass. All right, that's a particle. So the position versus time graph is going to graph position on the vertical axis and time on the horizontal axis. Note that the quantity is position. It is measured in meters. The quantity is time. It is measured in seconds. Meters and seconds, obviously, we could put any units here, but these are just going to be the ones we use in physics most often. We always put time on the x-axis. All right, here are the key ideas. First of all, I ask you here to write a verbal description for this graph and describe the exact mathematical relationship. Pause the video now and practice this on your own. When you come back, I'll tell you the answer. As promised, here is the solution. This particle is advancing forward 0.5 meter for every second. If we notice here, in 1 second, we've traveled forward 0.5 meter for every second. And if you think about that, you see this happening every single second on the clock. We move forward 0.5 meter for every second. Move forward 0.5 meter for every second. This description, for every second, is a useful way of describing the slope of the line. So this equation is the position of the object is 0.5 meters per second times the number of seconds. These questions help support that solution. Again, take a moment, answer these questions. These are my solutions to the questions here on the page. These three are read off of the graph pretty straightforwardly. I'm guessing the last one is the one where some of you might have some questions. This buggy is moving forwards at a constant velocity. I know that because on the graph the slope is constant. The definition of velocity is here. I'd like you to always start by writing down the definition of any quantities you're calculating. Then I take the numbers that I got from the previous questions and I come up with a solution after I do the division there. This quantity, by the way, I wrote it down as velocity. What we just found is average velocity. We already decided, or I already described, that this velocity is constant because the slope is constant. But if this object had been moving at changing velocities, we would still do the exact same calculation. Average velocity is defined this way, therefore calculated this way. Let's turn the page and pick up on the next side. Story B has you working at really similar questions about a different situation. I encourage you now, go off and practice those. I'm not going to discuss them in this video, but your practice will be a good way to spend time understanding the graphs. When you're done practicing, come back to the top of page 7 with me. Top of page 7 has you practicing some problems about taking a verbal description and converting it into a graph or a mathematical relationship. So this idea that we should be able to translate between different representations of motion is really important. Again, this is more practice for you. After you've practiced these problems, pause the video, practice the problems, come back and let's chat. Now that we have an understanding of how a position versus time graph works, you're ready to solve problem set 1. There are 2 problems here, and finally, at the bottom of the page, after you've answered both problems, I ask you about the learning objectives that these problems had you practicing. If you flip in the packet back to page 2, there's a list of the learning objectives for the unit. This is the bottom of page 2. Study these objectives and figure out which ones you practiced in this problem set. This is a metacognitive exercise. I want you to think about your thinking. It'll help you understand where we are in what we're learning and place it within the context of the whole unit. So please, after you do problem set 1, answer this question. That's it on position versus time graphs. There should be 2 main ideas you got out of this. One main idea is about the slope on a position time graph, and the other main idea is about the y-intercept of a position time graph.